Hi, question number 6. The complex number with modulus 1 and argument pi upon 3 is denoted by w. Express w in the form x plus iy, where x and y are real and exact. Now the first thing we need to realize is that the modulus of w is equal to 1, and the argument, the angle, has been given as pi upon 3. So to express a complex number, what we can do is we can say w is equal to cos of the angle, cos of pi upon 3, plus I sine of pi upon 3. And if we were to do that, you're going to get cos of pi upon 3, which is half, okay, plus I times root of 3 over 2. So in other words, we're saying the exact value of the modulus, of the complex number, is going to be equal to root of 3 over 2i plus half. And here we are for the first part. Now the second part of the question is asking us to sketch in an organ diagram showing the points representing u and v for the complex number 1 plus 2i. That's u in the beginning. So 1 plus 2i is somewhere over here. So this is u. And then you've got the complex number v, alright, and that's going to be v is equal to 2 modulus of u. But again, the argument is given as argument of u plus 1/3. So if we look carefully, the argument of u will be here. So that's the argument of u. Plus 1/3. Plus 1/3, 1/3 pi. So if you plus 1/3 pi, you're going to go in this direction, and then two lots of that. This is going to be the what is the argument? What is the modulus of u then? The modulus of u is 1 square plus 2 to the square from here. So we're saying root of 5. So the modulus of v is then twice, because they're saying it's 2. Right, 2 modulus of u, so 2 root of 5, so twice of this. Alright, so there we go, and then you get 1/3. So 1/3 is about 60 degrees, and so you're going to go into this direction, and let's say here, somewhere here. Alright, so this is v, and if we have to represent, so these are very important points here, pi upon 3. The examiner will look for this, for that, and that. This is 2 root of 5, and this is a root of 5. So here we are for the second part. Okay, for the third part of the question, explain why v can be expressed as 2uw. Hence find v, giving your answer in the form of a plus ib, where a and b are real and exact. 4 marks. The first thing we do is we look at w. So w was given in the first part of the question, where we had the modulus of w as 1 and its argument was pi upon 3. Now if this is the case, then we know that the argument of v, because they're telling us to express v, to explain why v can be equal to this, so the argument of v will be the argument of u plus pi upon 3. Now this part we had it in the second part of the question. This is where they're telling you argument of u plus pi upon 3. So this is now argument of u plus pi upon 3. And pi upon 3 happens to be the argument of w. So we're saying then the argument of v is equal to argument of u plus argument of w. And when we do that, we should be able to get the argument of u times w. That's the properties of argument. When you have addition, you multiply. And because there is a 2 here, okay, so the 2, that won't affect the length of the line, does not affect the angle. So length of line does not affect the angle. What I mean by that is that the length of the line itself, it's been multiplied by 2. the angle won't be affected. So therefore, what we can say is that the argument of UW is also equal to the argument of 2UW. So here we are, and now we're going to move on to the other part where we need to understand that, just move up here, the argument, the modulus of V is equal to 2 times the modulus of U. That's what's been given in the second part of the question. Using this in the third part, we can also say that this is 2 the modulus of U times 1. It doesn't change anything here. So basically what we're saying is that 2 multiplied by the modulus of U, okay, times the 1. 1 is also the modulus of W. So we can say times the modulus of W. So what we're saying then, we can put this in brackets, we've got then 2 times U modulus of UW. Alright, so this is the modulus of V. And that's the modulus of V, alright, so for V and UW and V, okay, the modulus and the arguments are the same, alright, so for V and W, the modulus, okay, and arguments are the same. Therefore we can say that this is V is equal to 2UW. That's what we've been asked to show. We show that the argument is the same, and we also show that the length is the same. And here, okay, now moving on to the real last part of the question. Hence find V, giving your answer in the form of A plus IB, where A and B are real and exact. So in order to be able to do this, what we're going to do is we're going to take what they're saying to us is that V is equal to 2UW. So what we're saying is 2 times U is 1 plus 2I times W, which is half plus root of 3 over 2I. If you multiply this, just a quadratic expansion, okay, 1 times half is half, and then 1 times the root of 3 over 2I, okay, plus 2I times this is going to be equal to I, and then 2I times plus is plus, and the I and I is I square, so using I square, which is equal to minus 1, so this is going to become minus 2 times root of 3 over 2 is root of 3, okay, and then if you multiply by 2 out, you're going to get cross out 1 plus root of 3 I, okay, plus 2I, and then minus 2 root of 3. Okay, so I'm going to have to rearrange this. Rearrange that. Let us see how we can do it. So 1 minus 2 root of 3. Okay, then plus, that's the real part. Okay, this is minus 2 root of 3 plus root of 3. So root of 3 minus 2 root of 3. No, hang on. This is root of 3 and then I and I. So 2 plus root of 3. 2 plus root of 3 times I. Okay, so here we go. You can say 1 minus 2 root of 3, okay, plus 2 plus root of 3, okay, I. And basically this is your answer. So here we go. That's the complete solution to this question on complex numbers.